Hello everyone, hope you're doing well and staying out of harm's way. Today we're going to use truth tables for the first time, and I will post this video on your discussion board and you can do the 10 exercises there. The first part of this is to tell whether statements are self-contradictory, tautologous, or contingent. If a statement is self-contradictory, it'll have all F's under the main operator. If it's tautologous, that means it's true by definition, or a truism. True's under all the main operators. If it's contingent, it will have true under one and false under the other, at least be true some of the time together. So, in a truth table, how does this work? Well, you have a letter N. And what are the two possible values for N? T and F. It can be true or false. Since we have only one variable, we're only going to go 2 rows deep. If we had two variables, we'd have two variables and two truth values, so 2 to the second power, and that would be 4 rows deep. So, we're going to do what's inside the parentheses first. Okay, so N implies N is, again, true and false, because that's what you wrote for N the last time. And then true and false again. I can't do the main operator of this formula until I do what's inside. So true implies true is true, and false implies false is true. Okay, I'm going to number these just for ease of use. And you really have 5 columns. You have N, N in the horseshoe, and then N, horseshoe, and N again. So, to get the values under 2, how do I do that? It's 1 implies 4. So N implies, T implies T is T, and F implies T is T. What do I know? Both values under the main operator, and that's the operator that governs the largest part of the formula by definition, both of them are true. So this is a tautology. Okay, true in all possible variables. Then we have two letters. E implies F implies F implies E. And when you have two variables, E and F, you're going to need, as I mentioned prior, 4 rows. You'll see. So under E, since it's first, we're going to put true, true, false, and false. And under F, that's the second letter we come to, we're going to alternate. True, false, true, and false. Why? Not just because we just set some kind of rhythm, but no. True, 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 false, false, true, false, false. Those are the only 4 combinations available to us, and so that's why we did that. Under F again, we're going to do what we did under F before. We're not going to just alternate with true, false, true, and false. And when we find E again, we'll put the same values we did under E prior. Okay, now I can also see that the main operator is going to be this one here. The operator under, the horseshoe under 6 is the main operator. I have to do the others first. True implies true. We know by our truth functions that the only time that's false is when T implies F. Okay, then I can do this one. I can do 2 implies 4 in order to get this row. In order to get 2 implies 5 rather, in order to get 4. So true implies true is true. False implies false is true. True implies true is true. True implies false is false. Now, in order to get the whole, I'm going to use 4 and 7 in order to get 6. So just let me write that. 4 implies 7 to get 6. Alright, just keep it straight and I can know what columns to look at. So true implies true is true. True implies true is true. True implies false is false. False implies false is true. So, what did we find? There was true on 3 rows and false on the other. That means it's contingent. That is, its truth is contingent on, depending on the variable. So we just write contingent. If it was all true, we would have written tautologies. If it was all false, we would have written self-contradictory. Okay, so using those examples I just tried, you're going to do the examples assigned, which in that section are 2, 3, 5, 6, and 8. There are 5 problems for you to do, which you can see on Blackboard. Okay? Now, we're going to do something different here. We're going to be comparing multiple formulas to get the same effect. 6.32, we're going to take a pair of formulas and say whether they are contradictory, contingent, tautologous, or consistent. So let's take a look. We have two letters. We're going to look under D, two trues, two falses. Under B, true, false, true, false. Why? To repeat, I noticed that I have two variables, or two letters, and so it's two variables times two truth values, so 2 to the second power rather, and so it's 4 rows deep. Not true is false, not true is false, not false is true, not false is true. So I took care of the values under the negation sign. False or true, I'm going to use this column here, 1 and 4 to get 3. So false or true, it's a wedge, is true. False or false, false. True or true, is true. True or false is true. So I'm going to be looking at that main operator to compare it to this other formula. I'll do the negation outside these parentheses last, of course. So under D, same values as before, two trues, two falses. Under B, I alternate true, false, true, false. I can do not be, false, true, false, and true. I can now do D and the not be. True and false is false. True and true is true. False and false is false. False and true is false. The negation sign gets applied last. So what am I applying the negation sign to? The D, the and, the not, or the B? To the and. Why? The and is the main operator. So I'm going to negate what's ever under the dot or the and conjunction. Not F is T, not T is F, not F is T, not F is T. What do I notice about those rows in the two formulas? Identical. TF, TT, TF, TT. So what do we say about that? That is a tautology. Okay. Now we have these other ones where we're going to do two formulas here. We're going to also compare these two formulas. R is true or S is false, and S is true and R is false. Again, I need to do 4 because I have two letters. And where I find S again, I'll do what I did under S before. Don't make the mistake of putting the values of R prior under S. Keep to the same values. Otherwise you don't get the result that you want. Not S is false, true, false, and true. We have R. The R will govern the R or not S. We're not going to look under S, but not S. T or F is T. T or T is T. F or F is F. F or T is T. With R, only one has to be true. Remember, it's a disjunction. Not R is, not T is F, not T is F, not F is T, not F is T. Then we have S and not R, S dot not R, which means the S and the what's under not have to both be true in order for it to be true, otherwise false. So true and false makes false, true and false makes false, true and true makes true, false and true makes false. So I'm comparing those values with those values. This says TT-FT, this is FF-TF. They're opposite on every row. The T here, F there, T here, F there, F here, T there. So what does that mean? They are not self-contradictory this time, but contradictory, because you have, I'm going to abbreviate contradictory, you have two formulas. Something is only self-contradictory if it's inconsistent with itself. 6.33 is going to be next, okay, after this. But these exercises 6.33, you have what I call word problems here. And it just says, this is on 362, and I'm going to do number 1 and 4. Use truth tables to obtain the answers to the following exercises. The letters to be used in constructing the truth tables are given in parentheses. So you'll notice that in the first one, only two letters are given, B and I. And then you read it through and you'll see how this goes. So renowned economist Harold Carlson makes the following prediction. The balance of payments will decrease if and only if, I know that that's triple bar, interest rates remain steady. However, if it is not the case today, the interest rates will not remain steady, the balance of payments will decrease. What can we say about Carlson's prediction? So, I'm going to represent that as B, triple bar, I. However, is an and. And then you have, it is not the case that interest rates will not increase, or again the balance of payments will decrease. Okay, so we want to know the relationship between, we want to see what values we get under and here. This is a conjunction. The main operator is the however part that you read. So under B you have true, true, false, false. Then you have the triple bar. And then you have I. Under I you're going to alternate true, false, true, false. That's what we've been doing. When is B triple bar I true? When they're both true or both false on the same row. So true, true means true. True and false are not equivalent. Treat the triple bar as meaning equivalent. False and true is false, and false and false, triple bar false is true. We're not going to take care of the and yet. We can't. But under B we can take care of this. 2 trues, 2 falses. Under I, true, false, true, false. Okay. Under, we can do the negation next to I, which would be false, true, false, true. Okay, and then under, to get the or there, we would need what's under the negation of I and B. So, false or true, disjunction, that's true. True or true, true. False or false, the only time it's false, and true or false is true. Now, the negation is outside the parentheses here, and it's going to apply to the main operator within. The main operator is not the not, it's the or. So negation goes right to this column here. In case you were wondering, you're going to need that. Negation T is F, negation T is F, negation F is T, negation T is F. What do we know about these sets of values right here? They are self-contradictory formula. Okay, that is not, it can't be the case. What can we say about Carlson's prediction? Self-contradictory. Whenever it's true on this line, it's false on that line. False on this line, true on that line. So, self-contradictory. Okay, there's one more to do, and this is a lengthy word problem as well, but you'll see that you're only going to be given 2 letters and you should be able to do it. You have on number 4 on page 363, 2 astronomers are discussing supernovas. Dr. Frank says research has established that if a supernova occurs within 10 light years of the Earth, then life on Earth will be destroyed. Okay. Dr. Harris says research has also established that either a supernova will not occur within 10 light years of the Earth or life on Earth will not be destroyed. Is it possible that both astronomers are correct? If so, what can we determine about the occurrence of supernovas? You're given S and L. Well, really what the first doctor has said, Frank, is that if a supernova occurs within 10 light years of the Earth, then life on Earth will be destroyed. Okay, so that's simply S horseshoe L. I think we can see that. And then the second one says, the second doctor says, research has also established that either the supernova will not occur within 10 light years on Earth, or what's the rest of it now? Or life on Earth will not be destroyed. Or life on Earth will not be destroyed. Okay, so let's take a look and see if these are, what's the relationship between them. Again, we're going to need 2 trues, 2 falses, a true, a false, a true, and a false. If true, then true is true, false, true, true. We're going to go through the 4 rows here. Okay, so true, true, false, and false, true, false, true, and false. I can do the negation next to L, false, true, false, and true. I could do the negation next to S, false, false, true, true. The main operator is the disjunction. And we're not going to take the disjunction S or L, but the not S or the not L part. So F or F is false. F or T, T. T or F, T, T or T, T. So let's look at these values under the main operators. You'll see in each case they're not self-contradictory, nearly, but true and a false there, false and a true there. But then you have T and T on other lines there. They are consistent. That is to say, the values, there are two truth values on at least one line. In fact, the last two rows, third and the fourth, they are consistent. So that's what you're looking for there. Okay, so you should be able to do the other problems in light of what we've said here. Okay, good luck, and we will see you whether we can discuss it further later on. Bye-bye.